In this video, we present DMPC-Swarm, the first hardware realization of Distributed Model Predictive Control, short DMPC, on a UAV swarm. DMPC-Swarm realizes all three components necessary for a successful DMPC implementation. First, efficient and reliable wireless communication through a wireless mesh network. Second, a distributed and event-triggered off-board compute architecture to enable DMPC on nano-UAV swarms. And third, a novel DMPC method designed to handle message loss and communication delays, providing collision avoidance guarantees under realistic assumptions. All agents in the swarm communicate over a wireless multi-hop network. For efficient communication, they use the Mixer protocol. Mixer uses the concept of synchronous transmissions. The devices communicate in multiple synchronized slots, flooding information through the network. This creates an all-to-all communication topology. When a device sends data, all devices receive it with a deterministic and predetermined latency. Additionally, Mixer divides the operation of all devices into synchronous rounds, consisting of a calculation and communication phase, all while being robust against rapid device movement. DMPC-Swarm supports lightweight and resource-efficient nano-UAVs, like the popular Crazyflie. To address their limited computing power, we offload expensive computation to a few ground-based laptops, called compute units, CUs. Each CU donates its computing power to one UAV at a time. However, using a 1-to-1 ratio of CUs to UAVs is not feasible. This would be too expensive, demand high bandwidth, and hence scale poorly. We, therefore, use significantly less CUs than UAVs. A distributed event trigger schedules the computation on the CUs by assigning one UAV to each CU at every time step. With MLR DMPC, each CU solves an optimization problem for one UAV selected by the event trigger. Its outcome is the trajectory the UAV should fly. UAVs not selected by the event trigger remain on their current trajectory. The UAVs themselves run a local controller allowing them to follow the trajectories. The main feature of MLR DMPC is that it takes lossy communication into account. It allows us to formally prove collision avoidance of DMPC-Swarm in a theoretical analysis based on realistic models of the UAVs and the wireless communication. As a result, the guarantees transfer to practice. In our hardware implementation, this method allows us to control up to 16 Crazyflies using at maximum 3 CUs. The 16 Crazyflies fly in a confined space of 3.4 x 3.4 x 2.6 meters, creating a crowded environment challenging for collision avoidance. A Vicon motion capture system provides each UAV with its position. SafeSwarm provides a resource-efficient, scalable, reliable, and safe swarm control solution, on which further applications can be built.